Okay,
Hello,
so
guys.
yeah, so YouTube is probably on, so I'll turn on the video. Hi everyone.
Yeah, video is okay, so let's start with your plan. The channel and life is almost fully yours.
Okay, hi guys. So last time we talked a lot about interpolation, and actually interpolation took most of the time last stream. So I thought that maybe we can go even a bit deeper and talk more about interpolation, about its technical details, its like theoretical part. But first I want to tell you about some news that we have about the streams. So we came up with an idea that between my very technical and boring lectures about how Cascadeur rigging works, how to work with node editor, and there will be more and more scripting there. We should mix it with something that is easier to understand and something more fun. And the idea we came up with is a dev blog, because actually inside the team we have a review of what was done in 2 weeks. So we use the standard Scrum approach, and in this and our plan is we actually are already during this review showing what was done in all the different teams, and we have a video. We're recording a video always about what was done, demonstrating the most interesting features, the most interesting tasks, etc. So what we will do is we'll take this video and I will go through it, telling you about the features that we added, the bugs we fixed, etc. Trying to pick the most interesting ones. We'll see how it will go. I think it will be less than an hour, which is actually a good thing. I don't think everybody likes my technical lectures that sometimes take 1.5 hours.
My technical.
So, okay. So that's the news. And we'll start next Thursday. We will have a dev blog stream. Also, we're thinking about what time is most comfortable for all of you. So please, if you want to participate, if you want to watch the stream live, please participate in our survey that is in our channel about the streams, I guess, right, Ilya?
It's in channel poll and opinions in Discord, and it's also attached into description of video in YouTube.
Okay, thank you. So now getting back to today's stream, let's look through the plan that I have. This plan will actually include something what I would call a devblog demo, because I'll tell you about tasks we're working on right now inside that are connected to interpolation. So let's begin. So first we'll start with a recap of IK/FK interpolation. We'll look at it from a bit of dimensional perspective, so theoretical math perspective about the spaces that where the coordinates live and what their pros and cons. Then we'll look at the limitations for rotational and spherical interpolation. Then we'll go into Cascadeur FK interpolation that is used right now. I'll try to do it very briefly and not get carried away. And then we'll cover what interpolation we use for IK and why is it different and what are the limitations in IK. And then we'll start the features that we are developing right now. It's about interpolation for Hinge connections, what problems they have right now, both FK and IK, and what we want to, how we want to solve them. And we have two ways of solving them. One is codenamed global FK, and the other one is codenamed with spherical IK. And I'll cover it and try to explain it as good as I can. So okay, so now let's begin. By the way, if you have any questions, I will like wait a bit about the questions, like pause sometimes, ask if there are any questions. But if you have some very interesting question, you can just butt in and ask the question. So okay, now let's start, and I will start with the pause if there are any questions in the text chat and the voice chat. I guess no.
Comment not on YouTube or Discord. Also, I want to add about good text questions. You can also write them in Discord. I will check it and I will forward them to the session.
Okay. So let's start.
Hey, I have one.
Start.
I have one question. Hey, I have one question.
Okay.
Sorry. One question.
Artem, turn off YouTube audio.
Yeah, there is a problem with setups like this. We were thinking about it, that we will mute if anybody has these problems. Okay, so are you ready to ask the question? Okay, Ilya, am I here?
Yes, you're here. Artem was silenced, in silence this time.
Maybe if you silence him, you have to unsilence him so he can ask.
No, I didn't mute him. He muted himself.
Okay. Okay, then I'll start. Whenever you're ready, you can ask the question. I think it's okay to interrupt me. Okay, so a bit of a recap on IK and FK interpolation. So we have different interpolation for different points, and for points, for the root point, for hand and feet main points. In IK we use we interpolate global position. For other points, for most of the other points, in IK we interpolate a global vector from the parent to the point. So for example, for this point we interpolate a vector starting here, that starts here, ends here. For this point we interpolate a vector that starts here and ends here. For this one, interpolate this vector, and so on. By the way, for additional points, we also interpolate vectors that start in the main point and go to the additional point. For IK, those are 3D vectors. For FK, we use a different type of coordinates, and for directional points it is what we call pitch and roll, and length, but length is usually constant. And for additional points it's only there's only one data, that is the twist. That's basically how it works. Or this. And for pitch and roll, okay, let me open a graph editor, it will be a bit more convenient. To use graph editor. So this is pitch, and this is our graph editor is not really good, yes, and this is roll. And having said that, I wanted to today to go into some details about how this data, why this data was picked, chosen, how it works. So let's talk a bit about these types of data. So what do you have? Usually, if you have a global position, then you can interpolate it using linear interpolation, Bézier curves, etc. They all work pretty good, and there's basically no problem with that. But when we were talking about, yeah, if we use global positions for all the points, then they will start to squish. For example, let me rotate the character, and now I'll turn on Bézier interpolation. Oh, and actually I didn't, it seems like I didn't turn off. There's a setting here, interpolate level, that means what updates you do. So if I turn off the relaxation, 3 is the default setting and does update everything. But if I put 1 here, I will turn off the relaxation, and I will basically see the character as it is when all the data is updated and no relaxation is called. And you can see that global datas, they interpolate pretty straightforward. So if I have just 2 keys, they will interpolate via line. Or if I put linear interpolation, it's just a line, and that's all. And because of this, everything is squished here. And if I turn on IK, then the character looks much better. And that's because these vectors are interpolated, and each vector is interpolated on a sphere. Okay, so why a sphere? Well, basically because we want this point to always okay, something is broken here, to always rotate around this point. Sorry, I'll have to switch to another Cascadeur. And okay, and so okay, sorry. So let's come back here. You can define such stuff as global rotation, for example, or interpolation on sphere in different spaces. Let's take first. Let's talk first about rotations, because I think a lot of you are familiar with them. And usually, to define a rotation, you use what's called Euler angles. And like, if you look at the property editor in any 3D program, you will see that Euler angles are basically represented by rotations on the around the x, y, and z axis. And like, it's the default way of defining rotation, but it has its cons that lead to gimbal locks. So almost all animators know what gimbal lock is. These gimbal locks are because it is actually not possible to rotate, to have a three-dimensional space that defines rotation that will not have a I don't know if it's the correct term, but basically pole vectors, special points where you can change one or the other angle, and nothing will actually change. That is not a problem only for rotations. The same problem goes for example, coordinates on a sphere, which is essential to us because our point controllers are located on a sphere around this directional controller. Okay, let me open it here. It's a true devlog because there are bugs in this version. Actually, you know what? Let me close it and go back to this version. Okay, so now I can rotate, and well, it's pretty obvious, I think, that the length of this edge is should always be constant, and that means the same, that this point is going around a sphere around this point. So okay, let's go back here. So what does that actually mean? That means that means that if we want to somehow say how this point is located in the space, and we know the position of this point, and we want it to use forward kinematic, and here actually maybe for some of you who are not very much into animation and don't know what was forward kinematic, inverse kinematic, usually when we are talking about forward kinematic, it means we are talking about the space of so we're talking about some coordinate system that already sits inside a coordinate system of the parent. So it is a local space that is placed in the coordinate system of the parent of the object. For the head, for example, it's the neck. And if we are talking about IK, then we don't want our parents to somehow affect us, and so we're talking about some coordinates, some data that sits in the global space. So if we have this point, this parent point, then we know that this point is located on a sphere, and so we have to define the position. Okay, let me call it child, and this one parent. So we have to define the position on the sphere, and the standard thing is spherical coordinates, and they're basically very close to what's used. You know, the longitude, how we define a position in the like a position on Earth, the coordinates on Earth on the maps. So they're very close to it. So what does that mean? What is this coordinate system? Well, this coordinate system, as we all know, it has two poles, like, you know, the North Pole and the South Pole, and those two poles are points where stuff gets really bad. Like the grid, the coordinate grid is smaller and smaller, and these are basically for interpolation. I would say those are bad points. It's pretty much the same for Euler angles. It's just that in Euler angles the dimension is higher. So if you want to define something on a sphere, you need basically two angles. Let's call them alpha and beta. And if you want to define a rotation, you need three coordinates. But this this bad behavior that will have on the poles is especially bad if you're talking about not setting some concrete rotation in a frame, but if you're talking about interpolation, because the space itself is disturbed a lot, and the interpolation gives really bad results. And the standard thing for the Euler angles is to go from a three-dimensional space to four-dimensional space. Maybe some of you heard what are Quaternions, and then in this higher dimensional space you will be able to construct interpolation that is much better. But the cost sorry, but the cost for it is that you need to control more. So for example, with Quaternion you have I don't know, 4 numbers, A, B, C, D. I think in 3D they are sometimes different, but okay, never mind. So these 4 numbers, these 4 floats, they're less obvious for understanding for people, and also the problem with them is that there's just more of them, and the same. So they're kind of harder to control, but they give better and more stable interpolation. And the same goes for our points which we want to interpolate on a sphere. We can go to a real 3D space and basically just use x, y, z coordinates that are basically the vector coordinates instead of this alpha beta, and in such a 3D space you can create a much more stable interpolation, but it's harder to control 3 floats instead of 2. So each space has its own pros and cons. That's what I wanted to cover. Yeah, and about the number of dimensions, there's actually a theorem that I mentioned here that is called Hairy Ball theorem or the hedgehog theorem, and it basically says that you cannot construct a space. You cannot construct a coordinate system with just two numbers to create a coordinate system on a sphere that will not have any poles. So and the same basically goes for higher dimensional spheres, and rotation is a sphere, in roughly speaking. And so yeah, that's the problem. And how can you potentially overcome it? And we decided that we do want a low dimensional space for FK, but we really didn't want any poles. We didn't want users to encounter poles. So we decided to go with this what's called a dipole field with index 2 coordinate system that actually has only one pole. To be honest, I'm not very sure that this is a large success. It is not very obvious, this pitch and roll they are in this coordinate system. I wouldn't say they are that obvious and that nice, but better than having just 3 float numbers for the global rotation. So okay, now let me go back here to see what else I have prepared. So maybe there are any questions?
We have question from Artem, but he wrote it on YouTube, so I can forward it to you. Maybe about box customization. Maybe when you have some time, you can show us how to change color on something like that.
Yeah, sure. Maybe even at the end of this stream, if you remind me, I will cover it. It's pretty easy, although probably it needs some automation. But if I remember correctly, then you can change the color of the box, just not by default. You'll have to go in another editor and add a color basically, and plug it into the behavior editor. Okay, so if there aren't any questions, I'll just go to the next topic. And okay, maybe I can just waste a bit of time to show a bit more about this pitch and roll stuff. The way I like to do it is I'll just create 2 keys and place a linear interpolation here, and I will try to go, okay, let me put some values here. So suppose they're 0, 0, and now I'll copy this key here, so I'll just have 0 pitch and 0 roll, and then I'll go with a like -70 pitch and to 70. I think I have some non-zero twist here. Let me put it to 0, and now you can basically see the trajectory. Okay, so you can see this trajectory. The pitch is changing, and now let me just grab the roll and show you how the pitch changes when you have different values for the roll. So it basically goes like this, which is, I don't know, maybe not ideal, why we could use that for FK, although it has there is a pole in this space, but it is located in a zone that is basically unreachable. The pole is located here, and it's impossible for human body to bend 180 degrees anywhere but in the arms and the legs. But there in arms and legs we have a different type of interpolation. We just have one angle that defines the swing, so how much the arm is bent, so we don't encounter these problems there. Okay, so this is just a bit of like practical, just a bit of information so you can see what this pitch and roll and dimensions mean on in the software actually. So now I just wanted to say a bit about the IK, and for IK, as I said, we use this global vectors, and that is mainly because unlike in FK, where we know that the head will never bend 180 degrees and it will never reach the pole, in IK we of course are not aware of this, and actually it can rotate in 180 degrees. You know, if your character is doing a somersault or basically just stands on its head, then the whole body turns 180 degrees, and of course all the points here turn, all the vectors in the global space, they turn 180 degrees, and because that is very possible and there's no problem with it, we can't use spaces that will have pole vectors. We can't use spaces that will have gimbal locks, etc. So we have to use a space that is very smooth. Okay, now we can go here, and I've prepared a scene. I showed it, by the way, I showed it last time with this directional object, where you can see how this is a direction, and you can see that how it stays on the sphere, and interpolation can work and it will be smooth and nice. The radius will not change, and that is what we want for our points. So but I have to say that this interpolation is not a standard one, so it is on a sphere, but it is basically constructed with a space that looks at the sectors that are drawn between the positions of the points on the sphere, and it interpolates in terms of the sectors. But let's not go into more mathematical details. Let's just stop at this and go for the next topic I wanted to cover, and that is interpolation for hinge connections. Yeah, so right now for hinge connections, what do we have for hinge connections? Basically we have, okay, let me correct this. Right now for the hinge connections we have two options. One option is that we interpolate with IK, and with IK for hinge connections this point is interpolated in global space and its position, not direction vectors as we have here, but its position, global position, is interpolated. And for these 2 points they are controlled by the pole vector. The pole vector is interpolated with this direction, with this sphere interpolation. So this vector starting from here, pointing to here, is interpolated. Let me just draw it so it will be more obvious, because I really want this to be understandable. Okay, so the obvious problem with this is that if you have, for example, your arm going here, then here, and you turn on interpolation, then if you look, oh, and let me turn interpolation back on. So okay, now this is a bit too much. I think I've overdone this a bit, or I have to just place this one here, and because it's using sphere interpolation, if it rotates more than 180 degrees it tries to rotate through the other way around, especially because it has some velocity from here. But okay, that's not the problem I wanted to point to. The problem is that suppose I want my arm to actually swing, and by the way, you can see this limb that is what's usually called a shooting angle, that actually shoots because it changes, the angle changes too fast. That's because when the arm is almost in a straight line, the angle changes much faster for the same change of the position. Let me put linear interpolation here. You can see that it changes very fast here and not so fast here, because when it is bent for the same amount of this point movement, the angle changes much less than it changes here, close to where the arm actually forms a straight line. It will be even more obvious if I do it like this. If I play the animation, you can see how it shoots the arm here and there. Okay, so that's a problem. I want my rotation to move in an arc. I want my hand to move as an arc, and then the only option I have is to put on FK interpolation, and now it moves as an arc. Might be not ideal in some ways, but still it moves in an arc. But the main problem with this is that if I let me fix now this trajectory, so I will see it even if I select something else, and let me select this clavicle, and the problem here is that it is affected by all the parents. So if I set some positions for the hand and I turned on interpolation, and now I go and try to change something in the body of the character, then you can see that changing anything here affects this rotation a lot, because it inherits the interpolation itself. It is done inside the space of the parent. So the rotation of the parent changes, the local coordinates change a lot, and yeah, the rotation was the same here but changed in this middle frame, and so everything changed. The trajectory of the hand changed very much. And for example, if you're animating a character that is swinging a sword, you probably really want to keep the trajectory that you had on the sword. So this becomes a really big problem. And what we want right now is to kind of combine the pros and cons for the both from the current FK and the current IK. So as in IK, we don't want the rotations of the parents to affect trajectory, at least to affect very much. And as in FK, we want the trajectories to be curves that are basically not bending the arm, and ideally we don't want any shootings in the arm to appear. So we came up with two solutions, created a very like alpha test versions for them. Okay, let me open them. Okay. Okay, this is not very nice. Oh, sorry. Yeah, I'm using the wrong version of Cascadeur. Okay, I hope this is a good version. So this are development versions. Okay, so let's start with this one. It's a bit easier for me to explain, probably. And this is what is called. Yeah, sorry, I have some tangents on the head interpolations. Works a bit strange. Okay. I have to put back the setting about interpolation level, and now I'll re-interpolate everything. And so the idea of this, what we call Spherical IK method, is that basically we have this vector that is starting in the shoulder and goes to the hand, and you have this vector everywhere calculated in all the keyframes, and then we interpolate using spherical interpolation for this vector. So it interpolates it, so that actually means that if the arm doesn't bend, then it stays on the same radius. If it bends, the radius itself is interpolated like as a separate value. And so the pros are it still kind of works on a sphere, so it doesn't bend too much. Okay, here it's like an extreme, a bit of an extreme position. Let me just add some keys and rotate without the arm being bent. Okay, I'll unbend it. Copy the frame, and now I'll have several frames just to show how it works. Now I'll turn on Bezier interpolation and let's see the trajectory, and you can see that it is not working as a standard IK would work. You know what, we can actually I only set it up for the left arm, so let me just use mirror to create the same positions for the right arm of the character, and I'll put on Bezier interpolation and we'll just be able to compare the rotations. And you can see, for example, here that here the arm bends and here it doesn't. Actually, it's not that extreme. Okay, maybe I should have made larger angles, as it doesn't seem that extreme here, but you can see how the bending here, and here there is no bending. It will be a bit more obvious if I turn on linear interpolation. So now this hand forms, interpolates and moves in lines, and this still goes through the sectors on the sphere. Okay, the problem with this interpolation though, its main con is that you still can have this this shooting elbows, shooting forearms. So that is mostly because again, this radius that basically affects the angle, it is interpolated, and it can even be interpolated smoothly, but still the angle is calculated from this radius, and it's non-linear, and it changes more quickly when the arm is unbent than when it is bent. The pro though is that we do have this first, probably the pro is that the data that actually gets interpolated is this vector from the shoulder to the hand. So it is like the basic data, and it is an easy data to understand and control. And you also have this pole vector. It's still here, it interpolates, it controls the positions of these 2 points. So it's basically close to IK, but it is a spherical IK that works, that makes this hand go in arcs. And the other idea we had is actually closer to FK. This is a setup. Here, to make it pretty fast, I had to disable, I had to delete the pole vectors but if we implement it fully, then the pole vectors will be here, but when you turn on this kind of interpolation, they will not matter, as they don't matter in FK interpolation, and like they will be just defined by the positions of the points. And so the idea here is that we interpolate both of these points as we usually interpolate all the things, using this interpolation on the sphere for this global vector and this global vector. And then we interpolate this angle basically like by interpolating the angle itself. So it's, you can call this you can say that this point gets interpolated in somewhat like an FK, but because these two are interpolated using the global vectors, rotations of this, for example, clavicle point, they will not affect our interpolation in any way. And the con here is that these vectors are like this vector from the shoulder to the forearm. It's pretty secondary, so it might not be as intuitive as we would like. Yeah, and also these 2 points, they interpolate themselves. You can't control them with a pole vector, I mean in interpolation. But the large pro here is that this angle is actually interpolated as an angle. And so this is the same animation we had there. You can see maybe it's bending a bit strangely here, but the pro is there's no shooting in the forearm, because the angle is interpolating. It's like a persistent data, and it's interpolating and it's changing smoothly. So these are basically the 2 ideas we have. We're thinking about trying to implement both of them, switching them, and then maybe picking one of them and actually adding here as another type of interpolation, or maybe they will remain to be switched in the pole vector. We don't know yet, we haven't decided, but that's something we're working on. So I thought that maybe it would be interesting for you guys to know what we're actually doing. Okay, so actually it's that's all for today. Everything I had in my plans. Maybe there are any questions in the text chat or in the voice chat.
Text chat is clear. I suppose that guys was listening to you very carefully. They didn't wrote anything, but maybe in voice someone want to ask something.
Well,
I
seems like it's
suppose.
not. Maybe it was too nerdy, too mathematically complicated today, but I think we'll try with the def block next time and see. Maybe it will be more fun. There will be more questions, and then I still plan to get over to the rig generation overview, because I want.
Just a second. In the games, wrote to me that his microphone is not working, and I suppose that there will be a question.
Okay, great. So then I will still return to the rig generation process to just go over the scripts, so that if anyone does decide to dive in there will be at least some basic info to get going. Okay. So we'll wait a bit for the question.
If it will be question, because of for this moment, he wrote that he thinks that the idea of last interpolation is great. I didn't understood the second one, but first is great.
Okay. Yeah, but the I think it's pretty hard to understand technically, like the technique we plan to use. Oh, sorry, in the second interpolation, but like the results that you will have is that it is interpolated. It's interpolated pretty smoothly, maybe not very obvious at times, but smooth, and it is not in any way. Okay, let me fix the trajectory here. Damn. Here, I'll fix it, and now I'll turn the change the rotation of the clavicle, and you can see that the trajectory is not affected in any way. So if the character was moving and FK is on somewhere, then the trajectory could move a bit as a whole, but like it won't be changed dramatically. It will experience very small changes just due to if this point moves, then it will change a bit, but there will be no problems as we have as we usually have for FK. And the same actually goes here. Let me fix it. I didn't prove to you that the clavicle won't affect it, so let me just prove it very fast. You can see that it doesn't affect anything. And just let me turn FK here to show you how it will affect in case we have FK, so you can see that it can change pretty badly. It's hard to move it. You can see here. Oops. And it's because I'm changing here, but if I change it here, for example, it will be even worse. Or here. Okay.
Yeah, I do added some suggestions. You think in cases when pole vector is not used, like in FK, you can hide it or make it gray.
Okay, yeah. I think it will be nice to... we're actually thinking about showing like FK or IK on the points as well, but didn't have time to do it yet, but maybe yeah, we'll do it. Thanks for the idea.
Because it was not obvious for him.
Yeah, I understand, yeah. Well, especially for pole vectors, it's easier to show that they're not active, so yeah, we should do it.
And thanks from Solid. He should have to run, but thanks for the stream.
Okay, thank you for coming. Yeah, and by the way, I wanted to show how you change the color. So let me just create a couple of joints, so it will be a very easy rig, and go to rigging mode, add a rigging element, and we'll see this box controller. So now it is fully generated, and what I can do is open node editor. Oops. using an inner version, but I think it should work in the basic version too. So color, here it actually has a boolean value use color, so you can set it up to use it or not, but right now I'll just create yeah, and for colors, I don't actually remember, but I think we use a vector 3 value, and I think it can be static to define a color. Let me try it. Okay, so it's 0, 0 right now, and that basically means that it will be black. And I actually can even change it here, and 1 stands. Okay.
Is that with basic RGB, if you don't mind me asking, or what's are those values set?
Yeah, yeah.
Gotcha, okay.
It is RGB, but maybe if use color is empty, it is not used, or there's a bug. So let me just check it out.
Have you thought of possibly using HTML color codes, just like Discord uses, just for people who are familiar with that? You can just copy and paste a color instead of having to mess with values.
Yeah, I think I'm not sure we should use them for the basic, like, you know.
Right.
I'm not sure we should use them to hold the values of the data, but I think what we should do
sorry,
is.
I'm not trying to. All I was saying is, I'm not trying to talk over you, but I was going to say is, if that is the case and you do want to stick with RGB, do you think we can maybe get a color picker instead of again still messing with like each color individually? We could just have a slight color slider.
Yeah, I mean, we should probably have something like this
yeah, exactly. Like that. Yeah,
in
exactly.
here. It's just that right now it's basically the vector 3 of data that is used, and there's actually no setting in the data that this data is actually a color. I think we can just add it, and then we can have a color palette or like this.
Okay.
I think it will be the same here.
Do you think, one last thing then, instead of, I know that those are with HTML, like, you know, hashtag or whatever. Do you think that you could possibly have a slight, like, how it says, like, hashtag FF000 for the red, for example? Could you have it to where it tells the RGB, like, color codes? So where if you just made, you know, you pick a color in there and it would just tell you what the color codes are, and then you can just type it in. Instead of having to go on, like, Google, for example, and, like, try to figure out what your RGB color is that you want to use. If you get what I mean, like, you would just pick something like that, and then instead of just also saying the HTML color code, it would also say the RGB values.
Oh, I see. You mean here, but
yeah, but just here, just anywhere. Yeah, exactly.
Okay. I think
we don't have to directly go into Google, you know, a separate application just to figure out the RGB colors and not mess around with it too much.
Okay, I see. Yeah, I think we can add like in this window, that in the color picker window, we could add a separate like place where it is represented.
Exactly. That's all I'm asking for. Yeah, exactly.
Yeah, but for this, for the datas that are stored in the scene and that are shown through the property editor, I think this RGB will be still the standard. By the way, here it works, so you can change it. I think RGB will be the standard way to see it, but we will have like something like a button here. You press it and you get the color palette. So, but in the color window, in the color picking window, you can. I think we should add just an RGB, this hashtag that is already there right now. So.
Yes, that's exactly what I meant originally. This isn't going to be related necessarily to that, and this is going to sound very random and niche, but I think this would be really nice for Cascadeur to have. Is there, or it could even possibly be possible right now, and I just don't know how you would set it up, say that you wanted like a tentacle creature, right? Like a squid, for example, or like a Medusa type of creature with like snakes in here or something like that. Could you go and basically, how can I put this? Like, you know how a squid kind of like curls its tentacle inwards, like that, like right with the tail on that? Could you have it to where it's with multiple points, like coming from a single point, and having it to where it's still doing its kind of like it does its automatic, like that, right? But if in the auto physics, for example, like when it's walking, it does the like automatic tail sway. Is there a way to make it to where if they were walking, each individual little tail sway would be on the ends, if you get what I mean? It wouldn't just be on one point, but it would be like almost like 5, for example, but I would still want that kind of like waviness to it.
I think it probably. Okay, so one thing is.
Go ahead. Sorry, I'm not trying to talk over.
Yeah, just want to say that one thing that it's pretty separate right now. So you have the rig,
Right.
and the rig it consists of rigid bodies. The rigid bodies are created only for the points. By the way, this spline IK that controls so there is much larger number of joints than the points, and then the rigid bodies, because if there are too many rigid bodies, it's a problem for the solvers, for the physics solvers. So we try to reduce the number of rigid bodies. It's still enough to like to reach some kind of realism, the physical accuracy, but the joints are bent via just a pretty standard spline IK. It has
No, I totally.
it has some modifications, but it's pretty standard. So.
Can I show you? Can I show you one example, if you don't mind me just sending you a quick video? It would be literally like 30 seconds.
Yeah, sure.
Okay, cool. Thank you. Here you go. It's inside the chat. It will be. It wasn't.
So I guess
Apparently there's in the chat for this one. So where should I post it?
maybe chat for streams.
Chat for streams. Oh, right there. I see it. There we go.
Okay, I see. So these are basically. So I think
It's just one little head, and you just you drag it around, and it just does that kind of like bounciness and like swing. You know what I mean? And then like you could also, with more nuanced like animation, you could do like full on tentacles stuff like.
Okay, so I think that with secondary animation this would work to some extent, although for such a large number of tails our secondary animation will probably lag a lot, because I think by the way, I don't know how they simulated it. Maybe it was not that like not that fast. Maybe they simulated it and then like it baked down on the animation the animation. But
right.
I also like we're not trying to get better than such physical solvers as PhysX, for example, Bullet or something else. It's they have large teams. They were developed for a long time, so it's I don't think competition with that is actually like sensible.
No, I totally get that. I just I was talking about more on the niche of just like again, we already guys do creatures, so I feel like things like squids and like squid hair. I've seen like other like characters that have like squid tentacles for like Dr. Octagonopus, for example. Like just having if you check out one last time that I sent one last thing inside chat for streams. It's from ZooTools. It's a tool spline rig. Basically, it's like you could do joints to curve and like controllers on curve, and basically you can go and set up things for like tentacles and anything like that really fast, and it would just automatically, you grab an end and it'll like curve in on itself.
Okay.
I don't know how you copied that weirdly. You didn't copy the link, you copied the Discord message. Just click it, just click it. Or like that.
It will open in a different browser, and it's I don't have like actually set up to okay, but yeah, with this tentacles, what I've at least seen people doing rigs, I forgot the word, but there are some techniques that are heavily influenced. So you have some starting position of the tentacle, and then you move it, and it recalculates. It's closer to what we have in our relaxation, but a bit different, more less stable. If you can't change the anything in between, but it is more stable if you change like the endpoint. So sorry, I forgot how the algorithm is called, but it's pretty standard. Maybe we will add it at some point of time, but
I do think like I know I said it even to begin with, it's niche, but I do feel like since you guys are kind of going for creatures and stuff like that, being able and you guys showed that like floatiness aspect to on that one video on 2022, I believe it was after the compensation motion. So like having that plus like having this, right? You could go and make a jellyfish just by dragging your mouse, for example, and you can make like a jellyfish wiggly animation. So having something as intuitive as that for stuff like this, and then being able to have just like a squid arm, and then you grab the point, and then you just curl it inwards with the auto posing. Like the auto posing would know it is trying to curl inwards on itself. Stuff like that would be out of this world, because other softwares don't do that to the point where I would like it to, and I feel like you guys would get it perfectly.
Yeah, I think that at some point of time maybe we'll try to cover this kind of rigs. Just to be, just wanted to make one more point clear, that auto posing, it's actually working only for humanoids, because that's basically a neural network that is trained for the humanoid body.
It would be able to tell. Yeah, okay.
Maybe we will be.
Is there any plans or to like be able to like detect if it's humanoid or non-humanoid or not? Because I feel like for again like a squid, for example, it's very simple in the sense of like it's a sphere with 8 things that are coming up, and then it tries to curl in on itself to the center. So like stuff like that, I feel like you'd maybe be able to like change, but I totally get it if that's not a priority.
Trying to make a very general neural networks that do anything you want is usually very, very hard, in my experience at least.
Absolutely.
We're maybe at some point of time we'll try to cover these rigs. We do want to cover more rigs. For example, there are even easier rigs that are not covered very good with Cascadeur right now. For example, like limbs that have several hinge connections are covered. Not as good as I would like them to be. At some point of time, maybe we will try to cover first those and then other ones. Although I'll be honest that right now we are concentrating on making auto posing better, because humanoids are still the most popular.
Absolutely.
And trying to make auto physics better. So that's our like primary goals.
I do feel like absolutely. I feel like with what you said with the whole making it work with multiple joints on a single limb, I feel like that would be a pseudo solution sort of for the tentacle thing that I'm talking about, like having shortest tentacles of like 7 to like 10 joints, and then being able to
but if those are hinge connections, then they can't bend sideways, and that's what a tentacle can bend. So usually hinge connections that are like this.
Yeah, right.
So you can just but you have but still, if you look from this way, you have this curve in only in one plane, but you have this curve, and you can. Right now, it's hard to control how much each of these angles is bent, and usually what you have is you can like kind of control inside this plane how this bending occurs. And that's what
exactly,
we
and if
lack
you
right
had
now.
that much more, if you had that much more parameter control, you would be able to sort of make tentacles a bit better for sure.
Okay, maybe. I think we can.
But
Solve
yeah,
this.
I appreciate you touching on this topic though. I was just curious on it.
Yeah, and thank you for asking.
Yeah, of course.
That's what these streams are for. Okay. So maybe there are any other questions or.
There is a question about Linux version, but I suppose that we already have a Linux version, as far as I remember.
Yeah, we have a Linux version, although I think we have some problems with Ubuntu, with the latest, with the Ubuntu 22, or it's 2022. I'll be honest, I migrated to Windows some time ago, although most of the programmers use Linux to compile Cascadeur, but we plan to fix that probably in the next version. But we have a Linux version. We don't have a Mac version right now. That's the main reason for like complaints about our support over different platforms. Okay, are there any other questions in the chat?
No.
Okay.
That's all for this moment. So I think that we can say goodbye to our YouTube friends, and after that we will say goodbye to Discord.
Yeah, I mean we're already kind of out of time. So
No worries. I really appreciate you sharing all your knowledge and doing these streams. They're very helpful.
thank you for watching.
I have a quick, absolutely. I have a quick question. Do you guys plan on possibly getting anybody like Stuek or like Quicksilver Sash to go and do not just like node based, but like everything that's been scheduled or like everything that's been shown off so far is very node editor heavy based. Is there ever going to be like just traditional animation stuff on just like, here, this is how you can go and do this, that, and the other, like with traditional animation in Cascadeur, instead of just a bunch of node editing classes?
We have it in the plans, as far as I know. Maybe we'll try to convince some of our users to do that.
It would be really nice. It's just because there isn't anything like that really on the channel, and like the more that we can get, like this is how you animate this instead of just walk cycles and basic backflips and stuff like that, the more that people are gonna like really start using the software. Like, for example, like one thing that still like really confuses me on one of the examples I saw was that breakdancing one where like he falls down, catches himself, does like the leg spin, and then like throws himself back up. Something like that seems very complicated. So like having a breakdown and like a thought process on how you would go around actually getting there would be amazing.
Yeah, we'll really try. Unfortunately, like animators inside the Cascadeur team are pretty shy about about doing live streaming and about like English skills.
Do you think even if it was subtitled, I'm being dead honest, even if they like just did tutorials and then you or just somebody else eventually did subtitles on YouTube, that would still be a super big help than whatever we have right now, which is basically like it's not nothing, it's not enough.
Yeah, you probably seen our like animation course.
Yeah, I have.
But it is pretty basic, because if you're and we like it takes time to create animation courses like that. They
Of course.
they're very polished, unlike the streams I do. They're very polished, thought out. So there was actually a Google document written and then approved and then rechecked and then changed and then translated and then there. And then
I
voice
do.
put on, etc.
I do plan on like really mastering the software over like the next 6 to 12 months. So if there still isn't literally anything in like the next 6 to 12 months, I'll just offer my service. Like I'll just offer to do it.
Oh,
you guys don't mind?
Yeah, that would be great. That would be great. But
yeah, absolutely. I mean, I would love to make a full course and everything like that. Just because, again, I would love to go over like sword tracking and things like that. Like you guys did a lot of demos, right? Like the character demos, like the robot and stuff like that. But it was just demonstrating like actual animations. Where if it was like demonstrating the breakdowns on like how those animations were done, would have been a lot better in my personal opinion.
Yeah, we'll try to do it. We have some plans with the subtitles too. Or maybe we were thinking about formats where like somebody's animating, and for example, I'm commenting a lot, just so the person.
That would be totally fine too. Like again, if they went and did like they went and said it in their native language or whatever they wanted to say during that time, you would already know what they're trying to say, so you'd be like, oh, this is what he's saying, like he's doing, or that, something like that. You'd just be basically like a voiceover on like some of the comments and stuff that he says.
Well, yeah, although I wouldn't be able, as I'm not an animator myself, I wouldn't be able to actually comment from the animator's perspective, but...
Right, true that.
But we're trying to figure it out, actually. It would be great,
I feel you. It's difficult. It's a difficult... It's not a like one quick answer solves it for sure. I totally get what you're saying.
Yeah, but we'll try it. I think actually potentially it would be really great if somebody like somebody from the from our user base,
from the community,
from the community participated. That would be awesome. Yeah.
I mean that's what I plan on doing. Like I mean I was just really hoping to see like a little bit more tutorials just to get me to that point. But if I really have to like go like the long way, and just really figure it out in and out, like I mean I don't mind that, but that's just gonna be a bit longer, obviously.
Yeah. Well, we'll try because there are of course a lot of animation tools, and like although we cover them, I think almost the whole tool set, we don't show how it is usually used on practice.
That's what I'm saying. Yeah, it's there's a difference between like this is what it is, and then like there's a difference between saying like that's what it is, and then like this is actually how you use it, and that's where I get a bit just confused because I know I've seen some like really complex like Cascadeur animations where I'm like, how the hell? I just wish I could know how to do that.
Although I have to say that probably some of them were like there was a lot of handwork there, but
for sure. But I do see a lot of like trajectory stuff. For example, like that's really complicated. That's like, damn. Do you guys have any videos right now on like motion paths for like swords? For example, like I know that you guys have like a constraint video, like where it shows how you can constrain like a sword to a hand. But do you actually have it to where you can set up a motion path for how you want the weight of the sword basically to swing?
Motion path. I'm not sure I actually understand it that well, but maybe you mean the trajectory of the sword, or?
Yes, right. So like you'd be able to click the sword, you'd see the trajectory on like how it's supposed to spin or whatever during the keyframes, and then it would actually be super awesome if you could just like directly edit that, like seeing the sword path like that's aimed in the key frame, and then you would see a visual representation in the viewport, right? And so being able to like edit those points inside the viewport would be, that would be so nice.
Yeah, I think you can actually do that. If I
don't think you can edit it in the viewport.
Correct.
I know that you can edit like the keyframes and stuff. Oh wait, you can? Wait, how did you do that? What?
So I fixed like what trajectories I see, and then I fixed trajectory edit mode. I think that probably this one is better for this stuff.
Yes. Okay.
And then you can actually see, and you can.
Can you do multiple points at a? Can you do multiple points at a time?
you can there's interpolation
there you
here
go.
right
Okay,
now.
yeah.
So if
Gotcha.
you move it, it will move. What
Perfect.
you can move these points. It will actually fix the interpolation here, but it's not very convenient in my opinion right now.
Right. Okay.
But you can see them. For example, let me disable. Oops. So let me disable this and select this once.
Yeah.
And
There you
then if you have, for example, a fixed interpolation or just a bunch of keyframes right here, what you can actually do to edit several poses is that you can go here to interval edit mode and set interval edit mode to neighbors.
Oh wait. Well,
And
I
now
didn't know that.
and now if you edit a pose, and let me just put fixed interpolation here so it doesn't reinterpolate. So now if I turn off interval edit mode, okay, now let me turn it off, and if I rotate it in some frame, then just this frame gets changed, and that's all. But if I turn on rotate, okay, sorry, and I'll put what isn't okay, yeah, okay, I go to neighbors now, and now you can see that only this, and I put, for example, Bezier interpolation, only this neighbor, when I move in
Perfect. That's
in
awesome.
this frame,
That's what I was looking
the
for.
neighboring frames will also change.
I didn't even know about the neighboring and selected modes. I really should look at the documentation a bit more. That's the only thing is like, do you guys have a video like showcasing the interpolation, like these modes and like what the differences are and all that sort of stuff? Or
I'm not sure. I think that, for example, this interval edit mode and neighbor mode is only covered probably in the documentation. I don't think it's covered in any videos, but
Gotcha.
maybe we'll do it.
It's just that's my only issue is just I'm a much more of a visual learner, and I know a lot of other people are, is to where like it's very difficult to like for them to actually it's a lot more exhausting to go through like documentation and like find everything. But no,
Yeah, but we'll try to catch up on that.
No, I appreciate all you guys' hard work though. You guys, this software is amazing, like truly.
Thank you. That actually really helps and motivates.
Again, I would really like. I know that you guys aren't going to be doing like any partnerships or anything like that. That's not what I'm talking about. But man, I would so love to see at least like some combo videos on like what you can do with this, and then like combine it with Ragdoll Dynamics, because Ragdoll Dynamics adds so much nice secondary motion afterwards that like it's like autophysics on top of autophysics.
Yeah, although we do have secondary motion, so for the character
you do.
body, we try to, although it's not a ragdoll in the mean that what we lack right now, we actually plan to include probably
if you guys had Ragdoll, oh my goodness, if you guys had Ragdoll. Like just actual collision is such a huge game changer. Like having the difference between of like, you know, how you guys did the box, the push box, for example, in with the the dinosaur, how him pushing the box and you guys did fulcrum points and like basically did like you guys kind of faked the like pushing basically, instead of just having a collision, like to where it's like, oh, this is how much force the box gets slid.
Yeah, but usually the dynamics you have is not very good. For example, for would not be very good for the dinosaur, but for the box, yes, the forward simulation.
Yeah, that's all I meant is like having like the dinosaur like have a head that like can actually hit it, and then like a box that will be. That's what I mean. And then like having a wall, and then having like your feet actually identified that's a wall, and stuff like that.
And we need collision for one more thing, not only for like ragdoll simulation, but also to automatically, for example, detect the fulcrum points that will occur somewhere.
Yes, that's exactly what I was talking about with the wall. Like, yeah, exactly.
Yeah.
That'd be really nice for wall running stuff. Just putting your feet there and it automatically realizes that's what
Yeah,
you're trying to
yeah.
do.
Although I have to admit it is rather long term, but
Oh yeah, absolutely. Even if it was like a year plus out from now, I mean that's still really nice that you guys are even just thinking about doing that. It just shows that where you guys are mindset wise as developers.
yeah, long term we do plan that.
Good, good, good. I'm glad to hear that.
Okay, so there are no more questions. If there are, then please ask.
Yeah, there were some comments from in the games. He says that he thinks that it's a good idea to show how animate because he didn't know about neighbors and also how do you zoom the manipulator. For example,
I use Alt and right mouse click. Sorry, I Control and right mouse click. My hands remember, but I don't actually already use my head to remember it. But yeah, I use Control and right mouse click, and it brings you the outer controller just to the mouse.
wow, it works. Comment.
Okay, yeah.
And about animation, for example, he offered just for walking on stairs that it would be nice. Or you can already key the fulcrum state by hand.
Yeah, although our physics right now doesn't support anything other than the floor very well, so yeah, unfortunately that it has some limitations.
Hi, do you hear me?
Yeah, hi.
I found the button. What I mean to say is if you go to the property of the object of the foot, for example, and you have button for fulcrum, not fulcrum, and
Yeah, I got you. Fulcrum and force, not fulcrum.
you can key them by hand, not let them to be calculated automatically.
Yeah, yeah, that's true. But
so I made once a couple of animations of going up and down like that, and it worked pretty well with physics.
Yeah, but it will work. But I have to say that it will be an approximation because right now the algorithm we use it actually it is such a thing. If I press, okay, let me press enforce here and put linear interpolation. So this is and turn on physics, and then okay, yeah, but okay, so let me move it up, and you can see that the support area, it doesn't go up, it stays where it is, and it's hard to say, but I would say that the further your feet go away from the support area, the more kind of bit of inaccuracy occurs there, I think. Although maybe I have to I'm not very sure it is so incorrect, but it is not 100% correct, unfortunately, as well. So I just have to warn you about this, that yeah, it probably will work pretty much okay in some cases, but in some it may give strange results because of this, because we use what is called a support area, and this force has to be this virtual fulcrum point has to be inside the support area, and if the support area is kind of moved around, then we'll have to go to a different mathematical model to cover it.
I think I understand.
But we do have some ideas how that could be covered, but we haven't gotten into implementing them because the out of physics we have right now still doesn't work as smoothly and goodly and universally as we wanted. But we will have a large update, I hope. In the next version, actually, in the next version, it won't be out until we have a pretty large update on this. So, like, I mean, it will still use the support area, but we hope it will work more stable. So, yeah.
Thank you.
Okay. Yeah. Thank you.
And I think that's all finally.
Okay. Thank you. Was very happy to actually chat with you using voice channels. It's really interesting.
Yeah, it was pretty interesting. Last 20 minutes, 25 minutes was you even seem to be more happy than usually.
Yeah, but it's very happy to interact with our users. Yeah, that's very nice experience.
Hey, Seth. If you don't mind me asking, just because I feel like everybody keeps asking this question, like it's like literally probably the #1 most asked question inside Cascadeur, which is the whole bouncing up and down thing with jumping for idle stuff. Do you guys have a plan to have a like a thumbtack like icon to where you can just click it and it's like sticky for like idle? It's like, this is an idle animation, don't jump.
Yeah, I think that again, probably a bit more long term, but
Okay.
we do want to. I think that like for the physics to work, we still have to make it actually move. So what we were thinking
absolutely.
about.
But couldn't you go and like isolate it to where it's not like necessarily it jumping? Like again, with that thumbtack thing or whatever, it would say this is an in place animation now. So it would slightly edit it to where that whole jumping aspect that it's trying to do, it would cancel that out and it would say, oh, okay, let's keep it to the ground, and then it would continue everything else that it's trying to do auto-physics wise.
Well, yeah, but for the physics to work and not get the model really complicated, I think that our main plan was that you press this button and it understands that, okay, this is an in-place animation, and then the most hard part of the plan is that it kind of figures out where are the fulcrum points automatically, and then it kind of just makes this animation and not in place animation only on the physical model, only on the out of physics model. And so you will see that the out of physics model walks forward, but the actual model just stays in place, and then if you press apply, it will also apply like in place, like canceling out that movement, like
very nice. Yeah, okay, I like that.
Yeah, that is the plan, but we'll see when we'll really able to do it. Okay.
And
yeah,
once again,
a 10-second wait to see if nobody else has any questions, because I'm afraid to lose this momentum when the people are actually asking questions. Didn't have it as much the last time.
Nope, I think that's it. Thank you guys so much. I really appreciate it.
Okay, thank you.
Have a good rest of your day, guys.
Bye. Good evening.
Bye.
Or good day to
good day, yeah.
Where you are.
So, bye-bye everyone.
Bye, guys.
YouTube is off.
Bye bye everyone.
Bye.